Good afternoon. This is Eric from 12 String Theory, and I just have a little something on carbon comp resistors that I want to talk about. It's kind of interesting. I'm gonna get a little into the weeds on this. Now, the carbon comp resistors were basically used in all the amplifiers made in the 60s and earlier, and a lot of the ones in the 70s too, because that's all that existed. And there's arguments about if they sound any different than carbon film and metal film and so on. I'm not going to get into that, but what I found interesting is I use a lot of surplus parts because availability isn't the greatest on these. And you can find a lot of these floating around. A lot of them are pretty old. They were, basically leftover stock from 50 years ago, maybe. And a lot of different manufacturers. Allen Bradley is a big one that had made them for a long time. Then there's also Kamaya, which I believe is a Japanese company. IRC is another one I've come across, in Stackpole, Omite. There's a number of them. But what's interesting is I had come across um, an old report on the IRC resistors that in this one application they were having failures when they were using IRC resistors versus Allen Bradley, because the Allen Bradleys had been discontinued. And they said that the construction was different, and it kind of piqued my curiosity. So I happen to have some IRC resistors. Now, IRC was around for a long time, and I know they were name branded, like under TRW had sold them, and they were IRCs. And so what I did is I took a few of these resistors and cut them in half, just to kind of look at the internals, because this thing about the IRC resistors is that they appeared to be the same as the old carbon comps, but they were internally different, that they had a glass bulb inside, and it was more like a carbon film resistor as opposed to a carbon composition resistor. The carbon comp resistors are basically a mixture of carbon and some binder and maybe a ceramic that's made into a cylindrical rod, and the leads are embedded in it and has some kind of insulation around the outside and so on. So the interesting thing is, if you look at these resistors here, the two on the right are, the top right one is an Allen Bradley, the bottom right is a Kamaya. And you can kind of tell that they're basically geometrically the same as far as the interior goes. There's some kind of insulator around the outside, and then there's a cylinder of carbon and whatever else they use on the inside. The one in the middle there is a stack pole, and again, it looks similar. It's a little bit different as far as it didn't fracture as cleanly, but it's clearly some kind of carbon on the inside. The one on the far left is a IRC resistor that does not have the same carbon on the inside as the other ones. So, does it make a difference? I really don't know. But if you're replacing carbon comp resistors, they will look the same, but the geometry and the internal structure isn't the same, for whatever reason. Now, what it seems like is the IRC and TRW resistors, the one in the back is one of those, and the one in the front, I believe, is an Allen Bradley. If you look very closely at the IRC resistor, it has a seam around it. That was probably a consequence of the manufacturing process. You compare that to the Allen Bradley, which doesn't have a similar seam. And from what I've seen, just with a somewhat limited exposure to them, is if that seam is present, then it is probably the IRC construction that has that weird bulb inside of it, or whatever it happens to be. But otherwise, the Kamaya and the stack pole don't have seams. So, the bottom line is, if you're looking at replacing carbon comp resistors in an amp for whatever reason, if you're using IRC resistors, they might look like the traditional carbon comp, but they probably aren't the same internally. Does it make a difference functionally? I can't really comment to that. The one thing I can say with certainty is the carbon comp resistors, they're really, you can consider them to be non-inductive because um, they don't have the right geometry to act as a coil. Basically, all of these things have an impedance. They're rated for resistance, but they'll have some amount of inductance and capacitance, which I think all passive components do. Um, but in the case of like a carbon film resistor, I believe the actual resistive element is in either a spiral or a helical shape. So it'll have some amount of inductance just as a consequence of the geometry. The carbon comps, because they're basically just a solid lump of some conductive material, arguably it's a composite, whatever it is. But it doesn't have that geometry that you'd find in a coil. So it won't behave the same as a carbon film resistor. Does it make a difference? I don't know. Maybe, maybe not. But if you think about it, a lot of the old amps, they put in a choke before the screen tap for the power tubes, and the choke was there to act as a filter, and it's an inductor. So it has to be, so that was designed to roll off the low end and take away hum, I believe. So if you have, maybe with a carbon film resistor, it impacts the frequency response in a manner that's different than a carbon comp just because of the higher inductance. I don't know. But anyway, yeah, carbon comp resistors, IRC, TRW, or any derivatives sure don't seem the same as the traditional ones, even though they look the same. So if you want something that may or may not work like it did 60 years ago, I'd stick with Allen Bradley. Crap, I think it was Yamaha. There's a Japanese company, stack pole. I'm going to keep cutting them open when I buy them just to make sure I know what I'm putting in these amps one way or another, because it matters something to me. Anyway, that's all. Take care. Bye now.